All right, 1.8 part 2 is solving absolute value inequalities. Last time I saw you, which seems like months ago, we talked about equations. Today we're talking about inequalities. These are very, very similar to when we solved inequalities in 1.7. Very, very similar. We're going to talk about the same kinds of things. You just have to make sure you thoroughly check. And I'm going to show you. We're going to go through 10 problems. It becomes redundant. I understand that. But if you go through the teeny check process, you'll understand. You'll find these two situations that could either be no solution or all real solutions that sometimes you may overlook if you don't check back and look. So if you guys notice this first slide, if I read these first two inequalities, 1 and 2, that sign says what? Absolute value of x is less than, yes, less than, right? That says less than or equal to, correct? All right, when I say less than, you guys, I always say and. That means something, okay? If you have just a less than sign, that means you're going to have an open circle, and your notation is going to be a parenthesis. If you have a or equal to, that means your circle is going to be closed, and that means we use brackets, right? But and means we color or we shade in between the 2 points that we found. If you have an or inequality, this says greater or greater than. This is an or inequality. Same goes for if it's open or closed with the less than or equal to, greater than equal to. If it's just greater than or less than, open, parenthesis. If there's the line underneath, that means or equal to, so that means closed and a bracket. If it's an or inequality, you shade this way or that way. Right? Okay, yeah. So we're going to do 10 problems right now. And I want you guys, every single one of these that you do, especially on your quiz, I want you to do the same thing I do so you can make sure you do the special parts. I renumbered these and I took some of them off from your original, so just follow along with me. But just like when we had our absolute value equations, we had to get our absolute value by itself. Once we did, then we rewrote the original, and then we changed the sign of the second one, right? Like if this was equals 2, you would have been x minus 5 equals 2, x minus 5 equals negative 2, and then solve. We're going to do the same thing, but there's one little extra step that you have to remember. So when I look at number 1, I first have to see, is my absolute value by itself? Yes, right? So I'm going to rewrite this. I'm good. I don't have to do anything. X minus 5 is less than 2. I have to solve another inequality. I have to say x minus 5, and I do agree, Camilo, I'm going to change this to negative 2. But you have to flip the sign. What do I have to do with the sign? Why do I flip the inequality sign? Because it's negative. In order for me to change that answer, in order for me to change the sign of the answer, I had to multiply or divide by a negative 1. That doesn't matter when you have an equal sign, but when you multiply or divide by a negative 1 with an inequality, what happens to the sign? You have to flip it. So if you guys notice, we flip the sign. You change the sign of the answer and you flip the sign. So now when I solve this, I'm going to add 5 to both sides. So I end up here, x is less than 7. I'm going to add 5 to both sides. And I have x is greater than 3. Everybody with me? Now that's not what I'm grading you. I'm grading you on your graph and your interval notation. So I'm going to go ahead and graph what I have here. Here's 0, 3, 7. Go back to your original question. This was a what kind of a problem? X minus 5 is less than. So I'm going to say, okay, remember, this was a less than. Where do we color when it's a less than? In between. And what kind of circle should I have? Open, because it's not or equal to. So I'm going to go ahead and do that. I'm going to put my open circles, and I'm going to color in between. Now, here is the check that you have to do for these inequalities. There's 2 checks you have to do. The first check is check your inequalities. My variable's on the left-hand side, so great. From 7, which way is this saying I should have colored? To the left. Did I do that? Yes. from 3, which way is this saying I should have colored? To the right. Did I do that? Okay, good. The second thing that I need to check, just to make sure, I'm going to plug in 0. If I plug in 0, should it work? No. So in my head, 0 minus 5. 0 minus 5. Negative 5. What's the absolute value of negative 5? 5. Is 5 less than 2? No. So that means I'm good to go. So first part of my answer is right there. How would I write that in interval notation? 3,7. Perfect. Brackets or parentheses? There you go. There's your answer. Now, we want to start the quarter off strong. All right, so here's my problem. The first thing I'm going to do is look at my sign. I'm going to identify what kind of an inequality I have and what my graph should look like. That says absolute value of x is less than or equal to, so it's an and problem. What kind of dots do I have? Close, good. And if I have an and problem, where do I color? In between, good. Takes 2 seconds. So now you go through the process. Get your absolute value by itself, is it? Yes? So rewrite your first one, x is less than or equal to 5. Rewrite your second one, x something to negative 5. What happens to my inequality sign? You flip it. So if you're going to graph this, you have negative 5, 0, and 5. What kind of dots did you tell me you're going to have? Closed. Which way did you tell me you're going to color? Now do our 2 checks. From 5, this inequality is telling me you should have colored to the left. Did you? Yes. From negative 5, this inequality is telling me you should have colored to the right. Did you? Then you're good to go. Plug in 0. Should it work? Yes. If I plug in 0, what's the absolute value of 0? 0. Is that less than 5? Yep. So you're good to go. So what's your interval notation? What to what? Negative 5 to 5. Okay. Brackets. Good. Why is it brackets? Because it's a closed circle. Because it's or equal to. There's your answer. Easy enough, right? Okay. Move to 3. I'm going to go through these first few kind of quickly. Again, identify your sign. This is an and. It's less than. That means it's less than or equal to. So I have closed circles. And less than is an and. I'm going to color in the middle. Is your absolute value by itself?
Yes.
Is there anything being added, subtracted, multiplied, or divided on the outside?
No.
No. So we're good. We can rewrite this as 2x less than 20. My second inequality is 2x is what? Greater than or equal to negative 20. You change the sign of the answer and flip the inequality. So go through the solving process. This is pretty basic. I'm going to divide both sides by 2. So x is less than or equal to 10. Divide both sides by 2. X is greater than or equal to negative 10. Now, to answer this question, negative 10, 0, and 10. I have closed or open circles. Close. Where am I coloring? In between. So check. From positive 10, I should have colored which direction?
Right.
From positive 10?
Left.
Left. Good. Did we? Yeah. From negative 10, I should have colored which way? To the right. Did I?
Yeah.
Okay, we're good. So what is our interval notation?
Negative 10 brackets, 7 brackets.
Perfect. It includes negative and positive 10. There we go. Questions? All right, moving along. Woo. What does this inequality say? Greater. That's an or problem. If I have an or problem, that means I go which direction? In the middle or opposite? Opposite, okay? Do I have open circles or closed?
Open.
Open, because it's not or equal to. Good. Is my absolute value all by itself?
Yes.
Yep. So 2x greater than 7. 2x is less than negative 7. You have to do both things. So algebraically, super easy. We divide both sides by 2. So x is greater than 7 over 2. Or divide by 2, and x is less than negative 7 over 2. So if I'm going to graph this, negative 7 over 2, positive 7 over 2, and you have 0. You guys told me it was open at both of these, and I was coloring which direction? Opposite, outside, because it's an or. So before you go and do anything, writing your interval notation, check 2 ways you can check. From 7 over 2, which way should I have colored? To the right, did I? Yes. From negative 7 over 2, which way should I have colored? Did I? Yes.
Wait, how do we know it's for again?
Because your original sign is a greater. Less than is an and. You're going to color in the middle. Greater is or, great or. You're going to color in the opposite directions.
Wait, if it's greater than or equal to, it's also.
Colored in.
If it's greater, what if it was greater or equal to?
Your dot would be closed.
No, I mean, if you still do the same thing.
Your just dot would be closed. So now if you're going to write your interval notation, guys, from left to right, where do you see red shading? From negative infinity to, no, to negative 7 over 2, good. Close that. I close it with a parenthesis because it's not included. Then there's a big gap. We call that a union. We're going to bring those two spaces together. And then it's 7 over 2 to positive infinity.
Wait, what's the union we need to put there?
That's right here.
Do we have to put
Yes, because you're joining those two together.
Did we get points off on the test?
I didn't on the test, no. But you need to have that.
Don't you put brackets around the infinity? Or no?
No, always parenthesis on infinity. Always parenthesis on infinity. But you have to have a union because it's this one and that you're bringing those two together. All right, so let's move on to some that are a little harder. Look, I took a couple of them off and I renumbered. So yours aren't going to look exactly like mine. I did change the sign on number 7 because I wanted to show something. But let's do 5 and 6. All right, first thing you do, guys, get in the habit of doing the same thing over and over again. Identify the sign. What does that say? Or, right? What does or mean?
outside?
Outside, good. What kind of circles do I have? Closed. If it's greater than or equal to, you're going to go the opposite direction. They're closed because it's an or equal to. That means I'm going to have brackets on those numbers because it includes. So now you just solve this the normal way. Is your absolute value inequality by itself? Yes. So you have two inequalities here. X plus 1 greater than or equal to 1. The other one is x plus 1 is what? Less than or equal to negative 1. You flip the sign of the answer and you flip the inequality sign. So if I'm going to answer this, I subtract 1 from both sides. I have x is greater than or equal to 0. Subtract 1 from both sides. X is less than or equal to negative 2. So if we're going to graph this on our number line, I have negative 2 and I have 0. You guys told me they were what kind of dots? Close, good. And at the beginning you told me it was a great an or problem, so you're going to go in opposite direction. And this is the way we check. 2 checks. Look at your final inequality answer. From 0, which way should you have colored? If I make a little arrow here, which way should you have colored? To the right, did we?
Yeah.
Yes. From negative 2, which way should we have colored? To the left, did we? Yes. So guys, read the green coloring. From where to where do values work? Negative what? Negative infinity to negative 2. What goes on negative 2? Bracket, good. Then there's a union, because there's a gap. Where does it start up again? 0 to infinity. And there's a bracket on 0. This is your whole answer right here, guys. You've got to have all of that. Walk me through number 6. What's the first thing I should do? What? Before I start doing anything mathematically. What does the inequality sign say? Greater than or equal to. So give yourself an idea. It's an or. That means I have closed dots because it's or equal to. And which way do we shade if it's an or? Outside. A lot of you messed up the shading and stuff like that because you just weren't. This little tiny thing really helps out when you're doing these complex problems because they're not all going to be real basic like this. You're going to have fractions and stuff like that. You've got to make sure you guys are on top of things. Every little bit is important. Now I look to see, is my absolute value by itself? Yep. So I rewrite this as 2x plus 1 is greater than or equal to 3. What's my second inequality look like? What's the second inequality say? 2x plus 1 less than or equal to negative 3. Good job. You changed the sign of the answer and flipped the inequality sign. So over here, I'm going to subtract 1. 2x is greater than or equal to 2. Whoops, forgot the x. Divide both sides by 2, and I get x is greater than or equal to 1. Over here, same thing. I'm going to subtract 1. So 2x is less than or equal to negative 4. Divide by 2. X is less than or equal to negative 2. If you multiply or divide by a negative, what should happen to your inequality sign? Flip it. Don't forget that. So if I'm going to graph my answer, I have a negative 2, I have a 0, and I have 1. What kind of dots do I have at negative 2 and positive 1? Close. Good. And according to my original assessment, which way should I color? Outside. So when I look at this to check, to make sure that I did this correctly, I can draw a little arrow right here. From 1, which way should I have colored? To the right, which I did. Good. From negative 2, which way should I have colored? To the left, which is what I did. Good. So how would you write your interval notation? Negative infinity to negative 2. Bracket, because it includes, union, bracket, 1 to infinity. If I plug in 0, should it work? No. So plug in 0 here. 2 times 0 is 1. Square root of 1, or not square root, absolute value of 1 is 1. Is 1 greater than or equal to 3? No, it's not. So then you're good to go. All right, look at number 7. Your number 7's a little different from mine. What did I change in number 7? Okay, the sign of 6. Should be just make it negative 6. Okay, we're going to solve this the exact same way. What do I look at first? The sign. What does it say? Less than. So it's an and. Open or close? Open. And if it's an and, where do we shade? In the middle. Okay, good. So I rewrite 5x minus 2 is less than negative 6. I rewrite over here. 5x minus 2 is greater than positive 6. Good. So go ahead and go through the motions. Add 2 to both sides. 5x is less than negative 4. Divide by 5. And I get x is less than negative 4/5. I'm going to add 2 to both sides. 5x is greater than 8. Divide by 5. And x is greater than 8 over 5. Everybody with me? Okay, so let's graph. Negative 4/5, 0, 8/5. How did you guys tell me I should color? Inside. So open circles and shade inside. Now, a lot of you will just stop and just go write your interval notation and move on to the next one. But the 2 checks I told you need to do. If I started at negative 4/5, what is my inequality telling me that I should have colored from negative 4/5? To the left. But where did we go? To the right. All right. From 8/5, my inequality is telling me I should have colored to the right. All right. So there's your first indication. Like, wait a second, something went wrong here. Not necessarily that you can just say, oh, I know exactly what it is, but something is not right. It's not the way that we did all the last ones that worked out nice and pretty. So the second thing you can do to check is to say, well, wait a second. Let me check some values. What is a number? Let's just check some numbers. What's a number that's less than -4/5? Guys, you have to be able to figure out what's a number that's smaller than -4/5. -1. Okay, good. So if I plug in -1 to my original here, what's 5 times -1? -5, okay, minus 2, -7. Is -7, the absolute value of -7 is what? 7. Is 7 less than -6? No, so nothing over here is going to work. Check a number in the middle. Plug in 0. What's 5 times 0? Minus 2. What's the absolute value of -2? 2. Is 2 less than -6? No, then nothing in here works. Pick a number bigger than 8/5. 9/5, but let's pick a whole number. It'll be easier. 2? Okay. 5 times 2 is 10. 10 minus 2 is 8. What's the absolute value of 8? 8. Is 8 less than -6?
No.
Guys, does anything work here?
No.
So your answer would be no solution. All right, if you get 2 answers and you go to graph it and you're like, wait a second, it doesn't match what I thought it was going to be at the beginning, you could have made a math error, or it could be one of our special cases. But there is a way that you can tell, and you could have told me that right here. Can anybody see why you could have told me that right there? Tell me.
Because negative and absolute value is never negative.
That inequality says the absolute value, whatever it is less than a negative number. Is that ever going to be the case? No. If you saw that there and pointed and said, no, and told me no solution, that's fine. If you didn't see that or you weren't quite sure, you didn't want to make a mistake, you get down to the end, you get you 2 points, and you compare what the inequalities were telling you to graph versus what you thought originally it should have been, and it doesn't match up, then you can say, ooh, I don't think this is right. Why isn't this right? And then you try points and none of them work, and then you're like, okay, I knew something was wrong, but now I really know. But that is a possibility, guys, you guys getting no solution. It's a very real possibility. Let's look at number 8. All right? Go through all the steps. We got 3 more to do. Go through all the steps. What's the first thing we do? Not yet. What are we going to decide first? What are we going to look at? The sign. Good. This says less than, so it's an and. What does that tell me about where I'm going to color? In the middle. What kind of dots do I have? Both of them are open. Good. You guys are getting really good at that. All right, so now we're going to get this absolute value by itself. You guys agree we're going to add 3. So 4 times the absolute value of x plus 2 less than 13. Guys, make sure your absolute value doesn't turn into a number. I was working out an answer key yesterday. It should be 16, yeah. I was working out an answer key yesterday, and I like a problem like this. X plus 2 became x plus 21. Just make sure your absolute values stay absolute values. So then divide by 4. X plus 2 less than 4. At this point, if you guys want to check it, all it says is the absolute value is less than 4. Could that be a possibility? Yeah. So that's fine. You can solve this one. So I have x plus 2 less than 4. X plus 2 greater than -4. So we're going to subtract 2. X is less than 2. We're going to subtract 2. X is greater than -6. So -6, 0, and 2. Whoops, and 2. Would you guys tell me what kind of circles was I going to have? Open, and color where? Okay, so let open, open, color in the middle. Now this is where we can check your inequalities. From 2, I should have colored which direction? To the left, did you? Yeah. From -6, you should have colored which direction? To the right, did you? Yes, okay. If you want to go one more step to check, plug in 0. Should 0 work? Yeah, so you can just do it in your head. What's 0 plus 2? 2. What's the absolute value of 2? Times 4. 8. 8 minus 3 is Is 5 less than 13? Yep, so you guys are good. So how would you write your graph in interval notation? -6, comma, 2. Perfect. And you're using parentheses because it's not included. Everybody with? Okay, let's go over into number 9. What does this say? What's my inequality sign say? Okay, so or, which means I do what? If it's or, which way do I color? Opposite, good. And what kind of dots do I have? Why are they closed? Because it's or equal to. Good, okay? So now we're going to concentrate on getting our absolute value by itself. So I'm going to subtract 8 from both sides. So I have negative absolute value of 2x minus 1 is less than or equal or greater than or equal to -2. What's the next step here? I'm going to divide by what? If I divide by a negative, guys, what happens to my inequality sign? It flips. So this now becomes less than or equal to 2. Is my original thought that I'm going to shade opposite directions the same? No. The reason that it changed mid-problem is because what did we do? We divided by a negative. You guys have to pay attention to those negative signs. This now becomes an and problem. Now, if you didn't notice that, right? You did the math right. You flipped the sign. But at the end, you were like, I should have shaded on the outside, but now it's on the middle. That's when you have to go, wait a second, let me check to see values. And then you might go back through and see, oh, I see the inequality sign flipped. You just have to pay attention. Now that my inequality is by itself, I have 2x minus 1 less than or equal to 2. 2x minus 1 greater than or equal to -2. So we're going to add 1 to both sides. 2x less than or equal to 3. Divide by 2. X is less than or equal to 3 over 2. Okay, so we're going to add 1 to both sides. 2x greater than or equal to -1. Divide by 2. X is greater than or equal to -1/2. Okay, so we go to graph. We have -1/2, 0, and 3 over 2. What kind of dots do I have there? Close. Now, remember, at the original, you guys told me it was an or problem, right? Yes? So if you would have gone and shaded on the outside, you then would say here, okay, look, from 3/2 did I go to the left? And from 1/2 did I go to the right? You would have seen, wait a second, my graph was wrong. That's when you would say, wait a second, let me check values. And then you could check values and see, oh, the stuff in the middle does work. And the reason it does work is because somewhere here in this problem, we divided by a negative, so we had to flip the sign. So you have to pay attention to those negatives. You got to pay attention to signs flipping. You have to check your graph and make sure it matches your inequalities and that values actually fall in those areas. How would I write my interval notation here? Bracket, -1/2, comma, 3 over 2, and a bracket. Good. All right, guys, we still have time. I want to do one more. What time are we out of here? 10? Yeah, we have time. I want to do this last one, and then we'll be done. I'll finish the other ones tomorrow. All right, what does my initial inequality sign say? Greater. It's an or. So that means I'm going to go in opposite directions. And what kind of circles am I going to have? Open, because it's not or equal to. So let's get this by itself. I'm going to subtract 5. 7 times the absolute value of x plus 2 is greater than -1. Divide by 7. I didn't divide by a negative, so I don't have to do anything with my inequality sign. Greater than or equal to -1 over 7. All right. Yeah, I didn't mean to do that. Just greater than -1 over 7. I'm trying to go fast. Now, my inequality is by itself. I'm sorry. My absolute value is by itself. I'm trying to finish up fast. I'm rushing, shouldn't do that. Absolute value is by itself. So I'm going to rewrite this as x plus 2 greater than negative 1/7. And x plus 2 is less than what? 1/7. Follow along with me, guys. I'm going to subtract 2 from both sides. So I'm subtracting 2/1. I have to get a common denominator, which would be 7. So this becomes negative 14/7, right? Negative 14 divided by 7 is negative 2. So over here, I have negative 15/7. I'm going to do the same thing over here. I'm going to subtract 2. So this becomes 7ths. Again, it's negative 14. So this becomes x is less than negative 13/7. So when we go to graph this, negative 15/7, negative 13/7, and 0. What kind of dots did you say we had? Open. Where do I color? From the original, what did it say? Opposite, okay, so it goes this way, it goes this way. Now, check where you should have graphed. From negative 15/7, it's saying I should have gone which direction? To the right. And then from negative 13/7, it's telling me I should have gone which direction? To the left. Oh, wait a second. If my graph looks a little wonky, what should I do? I should check. I should plug in some points. So let's plug in something to the left of negative 15/7. Pick a whole number that's bigger than negative 15/7. Or smaller than, I should say. Guys, do not pack up. The bell didn't run. Do not pack up. Negative 3. Okay, plug in negative 3 here. In your mind, what's negative 3 plus 2? Negative 1. Absolute value of negative 1 is? So 1 times 7 is 7. 7 plus 5 is 12. Is 12 greater than 4? Okay, so all this stuff over here works. Plug in 0. What's 0 plus 2? 2. Absolute value of 2 is 2. 2 times 7 is 14 plus 5 is 19. Is 19, wait, is 19 bigger than 4? Yes. The stuff in here works too. Here, guys, your answer is all real numbers. Negative infinity, positive infinity. The way you know that, look at this right here. What does that inequality say? Absolute value is greater than a negative number. That will always happen.